Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 1 from summer 2023. This paper is worth 80 marks in total, and this is the second video of 4. It will focus on questions 9 to 14, which account for 19 of these marks. AQA paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer. There may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 9. Erica tries to sketch the graph y equals 1 over x, with x not equaling 0. So y equals 1 over x is a reciprocal graph, or an inverse proportion graph. You may have heard of it that way. So this is Erica's sketch. We need to make two different criticisms of her sketch. So we've got criticism 1 and criticism 2. So the first criticism I'm going to make is about this point here. So the y equals 1 over x, the reciprocal graph, it never touches the y or the x-axis. It always approaches and gets nearer and nearer, like here, but it never touches it because there's a break in the curve when x equals 0. That's what this is all about. So the first criticism I'm going to make is it touches the y-axis. That shouldn't happen. It should never touch the x or the y-axis. The second criticism I'm going to make is where the second part of the graph is. Yes, there are two parts to this graph, but this part is usually in a different quadrant. By quadrants, I mean these 4 sections. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This section here is usually in quadrant 3. So actually, it needs to be reflected over the x-axis. But you don't have to go into that much detail. You can simply say that the curve in quadrant 2 should be in quadrant 3. There we go. You could say the curve in the top left should be in the bottom left. You can mention that it's wrong, but your criticism is that it's gonna be in the wrong quadrant if they were plotting the right graph. Question 10. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their ages is 5. How old is Joel? So again, we're going to form and solve equations here because we haven't been given enough numerical values to be able to do this otherwise. So, Sunita is X years old. Beth is 1 year younger than Sunita. So, Beth is X subtract 1 years old. And then Joel is double Sunita's age. So, Joel is 2x years old. The next piece of information we're given is that the mean of their ages is 5. To find the mean, we would have added these ages up and then divided by 3 for the 3 ages that we had. So I'm going to do that with these algebraic expressions for each person. So let's start by adding them. So x, add x minus 1, add 2x. So we would have added those together to get x plus x is 2x, plus 2x is 4x, and then subtract 1. So this is the sum of their ages, but we would have divided that by 3 because we have 1, 2, 3 ages, and then that would have given us this mean of 5. So now we've formed an equation. So if we solve this equation for x, we can substitute the x value into here for Joel and find out his age. So the first thing I'm going to do is multiply by 3 to eliminate this fraction. So when I multiply the left-hand side by 3, I'm left with 4x subtract 1. When I multiply the right-hand side by 3, 5 multiplied by 3 is 15. The next inverse operation I'm going to deal with is to add 1. And by adding 1, it eliminates the negative 1 on the left-hand side. So the left-hand side becomes 4x. And then when I add 1 to the right-hand side, 15 plus 1 is 16. The final inverse operation to find x, instead of 4 times x, I'm now going to divide by 4. So when I divide by 4 on the right hand side, 16 divided by 4 is 4. Now I know that x equals 4, I'm going to substitute this into the expression for Joel. So this is Joel's age, okay? So we said 2x, which is 2 times x. We've just found out that x equals 4, so that's 2 times 4, which equals 8. So Joel is 8 years old. Question 11. The Venn diagram represents 100 items, so all of the numbers inside this diagram must add up to 100. 11a, write down the probability of A intersection B. So this symbol is the intersection, and the intersection is this middle section here. So write down the probability that it's A intersection B. It's in both A and B. Well, there's 13 in that centre part, and we've been told it's out of 100, so our denominator would be 100. Part B, work out the probability that it's not A. That little dash there is the complement, and it means not. So everything that's not A. So we can't have anything that's in the A circle, but we can have this 48 and this 11. So 48 plus 11 is 59. Again, that's our numerator out of a total of 100. So we pop 100 on the bottom of our fraction. 11c, work out the probability that it's probability that it's A union B. So that's A or B. What this means that it's in the circle A and the circle B. So there's anything that's in these circles is included with that union symbol. So we have 28 plus 13 plus 48. We're not including that 11 because it's not inside any of those circles. So when we add those together, 28 plus 13, that's 30, 41. 41 plus 48 is 89. So we have 89 out of a total of 100. Question 12a. A multiplied by 10 to the power of n is a number in standard form. Complete the inequality for the value of A. So that's the value of this number here. So what we need to remember is that part of a number in standard form has to be between 1 and 10. So it can include the number 1, but it can't include the number 10. It's got to be between 1 and 10. 12b. B times 10 to the power of n is the number 7,200 written in standard form. Work out B times 10 to the minus n. Write your answer as an ordinary number. Okay, so let's start by writing 7,200 in standard form. So 1, 2, 3. So it would become 7.2 times 10 to the power of 3, because we're going to have divided it by 1,000. So that's 7,200 in standard form. But they want us to find B times 10 to the power of minus n. So B is 7.2, n is 3, so minus n would be minus 3. So now we're going to find out 7.2 times 10 to the power of minus 3. So the way we're going to do this is you've got 7.2. We need to move all of our numbers 3 places. 1, 2, 3. So actually it's 0.0072. Remembering that negative powers in standard form moving the opposite direction. Question 13a. Here is a number machine. So we have an input, some operations that we apply to that input, and then the output. So the solution that we would get when we follow through the machine. Show that when the input increases by 2, the output increases by 2a. So let's work through this function machine now, this number machine, and see what it is that comes out of it. See what expression we get. So we're starting with x, we're multiplying by a, and then we're adding b, which gives us y. Now, if the input increases by 2, we can do that as x plus 2 because that's 2 more than x. So let's go through this machine again, but now with our input as x plus 2. So we're starting with x plus 2, multiplying by a. These brackets are important because we've got 2 terms to multiply by a. Then we add b to get our output of y. So let's expand this one and then we can compare it to that first expression that came out of our number machine. So a times x is ax, a times positive 2, positive 2a, we have the plus b, and then it equals y. So when we look at these two equations that have been formed from the number machine, the difference between this first one and this second one is the plus 2a. That's what shows us that the output, the answer, increases by 2a because we've added 2a to it by adding 2 to that input. 13b, f of x equals kx squared where k is constant. Kai says that f of 6 divided by f of 2 is equal to f of 3 because 6 divided by 2 equals 3. Is he correct? Show working to support your answer. Okay, so let's work out what f of 6 is. So f of 6 means substitute 6 where there's an x in this equation here. So we've got k times 6 squared, which is 36k. Let's find out what f of 2 is. So f of 2, substituting 2 in instead of the x. So k times 2 squared, which is 4k. Okay, now let's work out f of 6 divided by f of 2. So f of 6 divided by f of 2 equals 36k divided by 4k. We can divide top and bottom by k. So we're doing 36 divided by 4, which is 9. Okay, so f of 6 divided by f of 2 is 9. Let's figure out what f of 3 is. So k times 3 squared, which equals 9k. So f of 6 divided by f of 2 is 9. F of 3 is 9k. So chi is not correct. They don't match. Question 14. Here is a list of 11 whole numbers in numerical order. The lower quartile, median, upper quartile and highest value are missing. So if these are in numerical order, then the first missing value must be the lower quartile, the next one must be the median, then the upper quartile, and then the highest value. So I'm just going to make a note for myself there. So the median is 2 times the lower quartile, the upper quartile is 2.5 times the lower quartile, and then the range is 2 times the interquartile range. So the interquartile range is the upper quartile subtract the lower quartile. So I made a note of that there as well so I don't lose my train of thought. So if these numbers are going in numerical order, then the lower quartile has to be 9, 10, 11 or 12. That's the numbers between 8 and 13. Now I'm going to start by using trial and error with a value for the lowest quartile because the lower quartile is included in 2 of the 3 calculations. So if the lower quartile is 9, then the median would be 2 times 9, which is 18. So if I look at the median box, the lower quartile can't be 9 because the median has to be greater than 19. So the lower quartile being 9 is not an option. Now let's start with the lower quartile equals 10. So if the lower quartile equals 10, then the median must be 2 times 10, which is 20. So that would work. The upper quartile would be 2.5 times the 10, which is 25. So when I get to here, This can't be 25. They're in numerical order. It's got to be bigger than 28. So a lower quartile of 10 does not work. Let's try a lower quartile of 11. So the median is 11 times 2. So that would work. The upper quartile is 2.5 times 11. Well, 2.5 times 11 is 22 plus 5.5. So that's 27.5. We're dealing with whole numbers. So that can't be the value. So the last one that we've got to try is the lower quartile being 12. So if the lower quartile is 12, the median is 2 times 12, which is 24. That would work. The upper quartile is 2.5 times 12. So 12 plus 12 plus half of 12, 20, which is 30. That works. So let's go with a lower quartile of 12, a median of 24, an upper quartile of 30, but we've still got this highest value to figure out. So the highest value we can find if we know the range, because the range is the biggest takeaway, the smallest, and we know what the smallest value is. But to find the range, we need to use the interquartile range. So the interquartile range is the upper quartile 30 subtract the lower quartile 12. So 30 subtract 12 is 18. The range is 2 times that interquartile range. So it's 2 times 18, which is 36. So to find the range, we would have done the highest value, take away the smallest value. So if we add the smallest value to the range, that will tell us what the highest value should be.